Hi, my name is Haley Vanderlinden, and for those of you who don't know me, I'm your 8th grade math CTL, and this is your Unit 1 preview. We are going to look at this unit on a day-to-day basis, but to start, let's go over our IB connections and star alignment. First, our statement of inquiry is shared characteristics help us understand complex relationships. This statement can mainly be explored in our language acquisition classes. While we are claiming that shared characteristics do help us understand complex relationships, we can look at different cultures in Spanish classes and consider these debatable questions. What are shared characteristics, and do cultures depend on shared characteristics? Now on to star alignment. This unit covers TEKS 8.2a, b, c, and d. 8.2d being the most important, given that it's a readiness TEK. These TEKs correlate to Category 1 on the star. While it is the smallest category and the least tested, it is, in my opinion, the easiest category and what I like to call gimme questions. Now on to our day-by-day breakdown, starting with day 1. Our objective is students will be able to approximate the value of an irrational number. I think the best way to teach this is by using a number line. For example, if a scholar is trying to find the square root of 45, he or she should know it is between 6 and 7 because 36 and 49 are perfect squares. You can also rationale that it is closer to 7 because 45 is closer to 49 than it is 36. All this said, scholars will have an opportunity to use a calculator on the star, so this lesson mainly provides a conceptual understanding. A quick fluency idea is to have scholars memorize the squares through 20 or 25. Day 2's objective is students will be able to describe relationships between sets of real numbers. This is a vocabulary-rich lesson, so we need to be sure to properly support our ELL scholars. However, the main focus of this objective is the use of this Venn diagram. For additional exposure, I would make sure these words are included on your word wall. I think this can also easily be turned into an anchor chart. Scholars will see this chart and other versions of this chart on assessments. For example, here is how it is tested on our Unit 1 assessment. Notice there are no headers to guide the scholars. Now looking at Day 3's objective, students will be able to convert between decimals, fractions, and percents. I think this is the most logical way to convert between fractions, decimals, and percents. To change a fraction to a decimal, you divide. To change a decimal to a percent, you move the decimal point 2 times to the right. That said, scholars do need to be able to convert back and forth, for instance, between decimals and percents, fractions and percents, percents and decimals. That said, I think this sequence will set them up with a solid foundation to do so. Another easy fluency drill would be to have scholars memorize benchmark fractions. Doing so would make all of the above work unnecessary. Day 4's objective is for students to be able to order a set of real numbers. This is arguably the most important lesson of the unit and correlates to TEK 8.2d, which is the readiness TEK in this unit. It is built upon Day 3's lesson. I would just consider reviewing place value. This is a common misconception. Although 1.23 is less than 1.5 and 1.80 is equal to 1.8, scholars can get confused because they think that a longer number means it is a greater number. Day 5's objective is for students to be able to convert between standard decimal notation and scientific notation. Here's a video that highlights the key points.
Math Shorts.
Scientific notation is a concise way to express very large numbers, such as the circumference of the Earth in centimeters, or very small numbers such as the diameter of an atom. Scientific notation is written as a product of a number and a power of 10. Here's a number in decimal notation. That's a small number. Time for scientific notation. First, move the decimal over until there's just one non-zero digit to the left of the decimal point. The exponent indicates how many places the decimal point has moved to the right. This is the same as saying 5 4/10 divided by 10, 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 divided by 10. Woo! A more concise way to show you're dividing 5 4/10 by 10 8 times is to say you're multiplying 5 4/10 by 10 to the power of -8. That's using scientific notation. The method is similar for numbers that are really big. To change from standard form to scientific notation, just keep track of the decimal. For whole numbers, the decimal point is at the end of the number. Move the decimal point so there's only one non-zero digit to the left of the decimal. the exponent indicates how many places the decimal point has moved to the left. That's the same as saying 4 and 75 ten-thousandths times 10 times 10 and so on, for a total of 9 times. Multiplying by 10 9 times is represented by the exponent, positive 9. Why do we need this number to be between 1 and 10? To make it easier to understand, compare, and do arithmetic with extreme numbers. To understand this number, you have to count up all the places to see if it goes to the millions, billions, or higher. In scientific notation, we can understand that the value of the number is approximately 4 with 9 zeros after it. At a glance, these two numbers look like they're almost the same. To know for sure, you can count the digits, or you can use scientific notation. We can see that the number on the right will be bigger since it is multiplied by 10 to the power of 10, whereas the number on the left is multiplied by 10 to the power of 9. Multiplying these numbers is a lot easier if you use scientific notation. First, you multiply the numbers separately. Let's round 4 and 75 thousandths and 3 and 95 hundredths to 4. The product of 4 times 4 is 16. Next, you multiply the powers. We know when powers are multiplied, exponents are added. Here we get 10 to the power of 19. The product of these two numbers is very close to 16 times 10 to the power of 19. As you can see, scientific notation makes it much easier to do math with extreme numbers.
Lastly, Day 6 is testing day. We want students to demonstrate mastery on the Unit 1 assessment. A couple quick highlights. This is the cover page I've created. Feel free to use it or not. I just think it makes it easier to track data by TEK. Question number 4 on TEK 8.2c is typically a confusing question. Be sure to emphasize that of means to multiply. For instance, 0.63 of 100 means 0.63 times 100. And lastly, if you're looking for an easy yet high leverage way to entertain early finishers, consider teaching them how to play Sudoku. My kids usually have mixed feelings about the game, but I like it because it's a stimulating post-test activity. And that's a wrap on Unit 1. Feel free to email me if you have any additional questions.